Lesson 5-4, the factor and rational zeros theorem. When a binomial evenly divides a polynomial, the binomial is a factor of the polynomial. The quotient of this division is called a depressed polynomial. A depressed polynomial has a degree that is one less than the original polynomial. We looked at that briefly when we did synthetic division. A special case of the remainder theorem is called the factor theorem. The factor theorem says the binomial x minus a is a factor of the polynomial p of x if and only if p of a is equal to 0, which just means if you have a remainder of 0, then that is a factor. For our first example, show that x plus 8 is a factor of 2x cubed plus 15x squared minus 11x minus 24. Then find the remaining factors of the polynomial. So we can use synthetic division here. I'm going to use negative 8 here because that makes it equal to 0. And then I have 2, I have 15, I have negative 11, and negative 24. I bring the first term down, I get 2, multiply, and I get negative 16. Add straight down, I get negative 1. Negative 8 times negative 1 is 8. Add straight down, I get negative 3. Negative 8 times negative 3 is a positive 24. I get a remainder of 0. So yes, x plus 8 is a factor. I'm going to put that over here. Then if I put the remaining parts, this would be x squared, x minus 3. So now if I factor this, this would give us negative 6x squared. Now I think, what do I multiply to get? Negative 6, but add them together gives me negative 1. That would be a positive 2x and a negative 3x. If I bring the sides down, I can factor out here. So I can factor out 2x. That leaves me with x plus 1. Over here, I can factor out a negative 3, and I get x plus 1. So my other factors would be x plus 1 and 2x minus 3. So these would be our factors. Next, show that x minus 5 is a factor, and then find any remaining factors of the polynomial. So again, I'm going to use synthetic division, so this would be 5. And I have 1, negative 4, negative 47, and 210. Bring down the first term. 5 times 1 is 5. Add, get 1. 5 times 1 is 5. Add, you get negative 42. 5 times negative 42 gives us negative 210. So we get 0 as our remainder. So this would be 1x squared plus 1x minus 42. So over here, I have one of my answers as x minus 5. That's a factor. So I need to know, what do I multiply to get negative 42? But add them together gives me 1. So that would be a positive 7 and a negative 6. So x plus 7 and x minus 6. Next, like this one. So factors of 3x cubed plus 10x squared minus 27x minus 10. So for this one, we could just pick one of those. So I just say 2. So check A. If I had 2 here, this would be 3, 10, negative 27, negative 10. Bring down the 3, so this would be 6, 16, 32, gives us a positive 5. This will give us a positive 10, which gives us 0. So A is a factor. This would be x squared plus x plus 5. So if I were to factor that, that would give me 15x squared. So what do I multiply to get 15? That gives me 16. So this would be 15x and x plus 5 and 3x squared plus 15. So I can factor out 3x. That gives me x plus 5, and this plus 1, x plus 5. So I can have an x plus 5, and the other one is a 3x plus 1, so letter E. Next part is the rational zeros theorem. The rational zeros theorem says if p of x is a polynomial function with integral coefficients, then every rational zero of p of x is of the form p divided by q, a rational number in simplest form, where p is the factor of the constant term and q is the factor of the leading coefficient. So if you see the example there, f of x equaling 6x to the fourth minus 23x cubed plus 23x squared plus 2x minus 8, given that 4/3 is a zero of f of x, it must be that 4 is a factor of -8 and 3 is a factor of -6. So they're just looking at factors of, so your p is your leading coefficient, or your p is your constant term, and your q is your leading coefficient. So if you write the factors over there and do the division, you end up with 4/3 as one of the options. So here we're going to list all the possible rational zeros of f of x. So to do this, this is our p, this is our q. So if we have p divided by q, this is 16, and this is 4. So all the factors to get 16. So we got plus and minus 1, we got plus and minus 2, we got plus and minus 4, we have plus and minus 8, and we have plus and minus 16. To get 4, we got plus and minus 1, plus and minus 2, and plus and minus 4. So for this one, we could get all possibilities of 1 divided by 1 is 1. So we have positive and negative 1. We could do 1 and 2, so that would be positive and negative 1/2. We can do positive and negative 1/4. And then all the other ones, 2 divided by 2 is 1. We already have that down. 2 divided by 4 is 1/2, so we already have that. 4 divided by 4 is 1, so we already have that one. 8 divided by 1 is positive and negative 8. We have 8 divided by 2 is positive and negative 4. And we have 8 divided by 4 is positive and negative 2. And then 16, positive and negative 16. 16 divided by 2 is 8. 16 divided by 4 is 4. So these are all the possible rational zeros we could have. Not all of them would work, but those are all the possibilities. Next, find all the possibilities here. So our p, our q. So we have 12 and then 3. So we got positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 4, positive and negative 6, positive and negative 12. And then for 3, it's just positive and negative 1, positive and negative 3. Let's do all the fractions first. So all the fractions would be positive and negative 1/3, positive and negative 2/3, and then the rest would be, we'd have positive and negative 1, positive and negative 4/3. We have positive and negative 2, because 6 divided by 3 is 2. We have positive and negative 4, because 6 divided by 3, or 12 divided by 3 is 4. Let's see. We had 2, we have 4/3, 3. So those would be all the possible solutions we have. On the last one, list all the possible rational zeros for this one. So we have our p and our q. So p is negative 56, and our q is a positive 1. So we can have positive negative 1, positive negative 2, positive and negative. So 56 divided by 2 is 28. So we're going to have a positive negative 28. The 56 divided by 4 is 14. So we have positive negative 4, positive and negative 7, positive and negative 8, positive and negative 14, positive and negative 28, positive and negative 56. And then this bottom one is just positive and negative 1. So that means our answers would just be everything in the numerator. So everything up here would be all of our possibilities for that to equal. So that is our lesson on the factor and rational zeros theorem.